Okay, so since this is the second part of our work on decimal conversions, I'm going to start with a quiz. What's 0.5 as a conventional fraction? Can you convert it? And if I move the hands of my clock here, I've now got 0.25, so that's the fraction of an hour, if you like, and that's 0.25, and again, can you convert that to a fraction? And finally, just to halve that, that will give me the decimal 0.125, and again, can you convert that into a fraction? So pause the video if you want to give that a go, otherwise I'm going to reveal the answer now. So I'm going to show the working here, and it's really why I'm doing this is because it's a recap of the previous video. All we did is we said that 0.5, well, that 5 is in the tenths place, so this must be 5/10, divide top and bottom by 5, and we get 1/2, which is a half. 0.25 equals 25/100ths equals 1/4, in other words, a quarter. And 0.125 equals 125,000ths once we've joined all the tenths, hundredths and thousandths together. And I've just divided through here by 5 to get 25/200ths, and then divided top and bottom by 25 to get 1/8. Now, if you didn't pause before, you can pause the video now to do something slightly simpler, in fact. 0.2, which would look like this on our clock face, and 0.1. So pause the video now. Okay, and let's reveal the answer. Well, 0.2 is 2/10, which is a fifth, and 0.1 is 1/10, and it's just been rewritten here. But of course 0.1 is 1/10 because it's a 1 in the 10th column. So what we've done there is we've shown all the decimals here that produce nice easy numbers, and that's because they've only got a few numbers here, and they don't do this thing that you see on the calculator all the time of having these decimals go on and on and on, sometimes forever. Okay, but what happens if they do go on and on forever? Let's have a look now at this. I'm going to just move that clock hand around, so we've now got a third of an hour, and we probably already know that a third is expressed like this. It's 0.3, and those threes just keep on going. Okay, so we can see that this is going to give us a problem if we use the method that we used before, because what we were relying on is being able to say, well, that's in the 10th column, that's in the 100th column, that's in the 1000th, and we're just adding those together. Well, that would go on forever because these threes go on forever, and the numbers would get just impossible. So we've got to think of a different method, and it's a very clever method, but it takes a little learning. So this is how it works. What I'm going to do before I start, in fact, is I'm just going to check what I've got on the calculator. So if I write a third into my calculator now, it doesn't give me this because it's a fairly sophisticated Casio calculator. What it actually shows is this. And this is a really useful symbol. This is the recurring symbol, you might know it already, and it simply means that 3 is repeated and repeated and repeated and repeated. If it was something like 3, 1, 4, and there was another dot, which we sometimes see, that would mean that everything here is repeated. So it would be 3, 1, 4, 3, 1, 4, 3, 1, 4, etc., etc., etc. But there's still a repeated pattern. Now, a third. How do we get to the answer? Well, we know the answer that is a third, but how would we actually calculate that using a written method? So we've got 0.3 recurring, and what we're going to do is we're just going to multiply that by 10 minus 1. And this is a little preliminary stage we do so that we can remove the recurring part, all these numbers that go on and on forever, get a single integer, which is what we need for a fraction, and then work out the answer. And I'll show you what I mean by sketching to one side what we need to do here. So we've got a 0.33. Let's just write these out. Okay, and we understand that that goes on forever. What we want to do is make sure that this recurring part, I'll just put the dot in here, is just to the right of the decimal place, in other words in the 10th column. And it already is in the 10th column. It might not be. It might be that the dot doesn't start till further down the decimal, and we'll see an example of that as we move into other examples. But at the moment it's exactly where we want it, so just by multiplying by 1, so times 1, we get what we want. We get this recurring number that we're going to, in a minute, get rid of. Now, how are we going to get rid of it? Well, if I write that recurring number over the top, I'm just going to get rid of that symbol at the moment so we don't get confused. So I'm just writing out all the numbers. Then what I can do is multiply this number by 10. And what happens when I multiply by 10 is that 3 is going to go up into the ones column, which is where I want it. So I'm going to get that 3 there. Now all the 3's move along. That one goes to there, that one goes to there, that one goes, and they all shunt along. But that doesn't make any difference to these recurring 3's. We've still got recurring 3's going on forever. And so 0.3 recurring, okay, 0.3 recurring is 3.3 recurring. Okay, I hope you can see that. So in other words, and if I write this out properly, I've got times 10 gives me 3.3, and I'll put recurring symbol in now, and I'll just remove all these 3's just to neaten it up. We understand that they're there, but we perhaps don't need to write them out. Now, if I've got the same top and bottom, if I do a subtraction, a conventional subtraction, so let's just, well, let's just do it to one side here. So let's write it out. Yeah, let's write it out again. So we've got 3.3. In fact, I'll write out the 3's here so you can actually see them disappearing. We've got 3 and dot dot dot, and we've got 0.333 dot dot dot. I'm going to subtract one from the other, so we want to know the difference between these two. That's why I've got a subtract sign here. And we're going to go left to right. Okay, so 0 from 3 gives us 3. 3 from 3 gives us 0. 3 from 3, 0. And you can see these zeros, well, it's going to go on forever. So another way of saying it is all these 3's just keep cancelling. Okay? Because 0, 0, 0, 0, 0, of course, is just 0. And so we can just say here that those 3's can be erased, giving us simply the difference between 10 times 0.3 recurring, which is 3.3 recurring, subtract 0.3 recurring is just 3. Okay, all well and good. But why is that useful? Well, if I say 0.3 recurring times 10 minus 1 in brackets equals 3, what is 10 subtract 1? Well, it's 9. I'm going to put my 9 there. And if I rewrite that, so let's just rewrite that. So that gives us 0.3 recurring. Don't need the times symbol now, we'll just use brackets times 9 equals 3. Then if I'm timesing by 9, I could, by the way, let's just write it. I think people are more familiar with this format, so let's just write it out like this. So times 9. So if I'm multiplying by 9 on this side of the equal sign, then I am going to divide both sides by 9, giving me 0.3 recurring equals 3 divided by 9. In other words, if 0.3 recurring times 9 is 3, then 0.3 recurring must be a ninth of 3, in other words 3/9. So I've said that in various different ways. You might want to pause the video and just look at this carefully to make sure you've got that clear in your mind. But 0.3 recurring must equal 3 divided by 9. Okay, so hopefully you've got that step, you understand it fully, and what we can now do is simplify the fraction. So we've got 0.3 recurring equals 3/9 equals 1 divided by 3. And there we are. We've converted 0.3 recurring to 1/3. Okay, it's a lovely nifty method, so let's have another go. I'm going to move the hand of the clock here, so we've got half of what we had before. We might already know the answer, but the decimal, my calculator tells me, is 0.16 recurring. So my challenge is to convert this, even though it's got all of those recurring numbers coming after it, I've got to convert it to a conventional fraction. To prepare the way, you would want to leave your working, but because we're trying to fit everything onto the one page here, I'm just going to remove these workings out. Okay, so how are we going to do this? Again, what the challenge is what you have to do is you have to get that recurring part to be just, well, in the 10th column. In other words, if I put my decimal point here, my recurring number has to go there. Okay, so I can't forget the 1, so I've got to put my 1 in, but this time it's going to jump the other side of the decimal point. What have I done to get it there? Well, I must have multiplied by 10, because that decimal point appears as if it's moved 1 to the right. In fact, the number has moved 1 to the left. If it's moved 1 place to the left, then it must be times 10. Okay, so I've already got my second part of that bracket there. Now I need the first part, the number that I am going to subtract from. So I write up my decimal point here and I put in my 6 recurring, and I don't want to put a 1 there, which is what I did before, but I've got all those 6's to play with, so I can put a 6 here, which just means I've moved one of those 6's, well, all of the 6's, but one of the 6's has tipped over into the 1's place, and my 1 in front of it gives me 16.6 recurring. In other words, that must be times 100. So if that's times 100, then the next part of my bracket is 100, and I can now subtract. So 16, subtract 1, well, very easy to do, I don't know why I put a fraction bar there. Okay, 16, let's get my pen back, 16, subtract 1 gives me 15. Okay, hope you're happy with that. 1 from 16 gives me 15, so my answer is 15. And what have I got in here? 100 subtract 10, well, that's 90. So it's not going to be the same, but it is always going to have one of these 9's in it, and you'll see that happening again and again. So that's the clever little bit of working out that we do to get to this stage. Now we just go for the conversion. So we say 0.16 recurring equals 15 divided by 90. Because if 90 times 0.16 recurring gives us 15, then we must have 15 times a 90th. A 90th of 15 must be 0.16 recurring. So that's given us our fraction. 0.16 recurring is 15 90ths. And 15 90ths are, of course, 1/6. Okay, let's do another one. So halve it again, and my calculator says, let's see, halve it again, and I get, it's an interesting one, 0.83 recurring. So let's remove our workings out again and work it out again. Okay, so now what I've got, well, again, I want that recurring part. Let's just move it out here. So I want my recurring part to be just the other side in the 10th column, in other words, like this. That must mean that my 8 is over the other side, and that means I've multiplied by 100. And you can see that if we go back to our original decimal here, I've moved the decimal place 1, 2 to the right. That means the number has increased. It's gone up, it's gone to the left 2 places, it's increased by 100. So times 100. Okay, that's the number that I'm going to subtract from. I'll write this out in a minute in the brackets. Let's just quickly go ahead and do the workings out. So what do I need now? Well, I need again my 3 recurring. I can't put an 8 there, so I'm going to put one of those 3's there, and that means my 8 goes over here. So now I've got 83. Let's just do it this way. Cancel that out, subtract 83 from 8. Well, I can count backwards to give me the answer to that, and that just gives me 75. Okay, double check. 75 add 8 is like 75 add 10, subtract 2, so 75, 85, subtract 2 gives me 83. So my mental check, very important to remember that so that I don't make a mistake, especially in tests and exams. All right, now I've done everything I need to, except I haven't worked out what this was. Well, it's gone one more place than this one, hasn't it? So it must be times 1000. So now I can do my brackets. 1000 subtract 100 gives me 900. So my multiplier this time is 900. It was 9 to start with, then it was 90, now it's 900. So it's good that it's changing each time. And the answer I got was 75. Okay, so let's rewrite this. We end up with 0.083. We can do this straight away now, I think. Gives us 75 divided by 900. And if you work that out, you end up with a 12th. Okay? Obviously, you might need to go to one side just to work that out. You might want to do an Hcf method, for example. So you might want to do something like 900 and break that down into, let's see, 5. Yeah, it's worth just working this out. 180, let's see, 5 again, 36, 3. Now the reason why I did that 3 is because I wanted to get 75 so that I could cancel. So I've got these 3 here together giving me 75. So 900 equals 75 times 12. So I've got, I can do this down here, 75 divided by, well, 900 we know is 75 times 12. And there we are, our 75s cancel, gives me a 12th. So that's how I would work it out if I was doing it, if I was doing it by hand, written method, if I wasn't allowed to use a calculator. Otherwise, I would just reach for the calculator and work it out from there. Okay, let's do another one. Let's see, so I'm not quite sure where this is going to go this time. Okay. So this is the proportion now of an hour. This is the fraction, and I can see on my calculator that that gives me 0. Oh blimey, this is 0.1. Okay, deep breath. 14285 recurring. Gosh. So it would then go 14285 14285 14285, etc., etc., going on forever. I can tell from experience that this is going to be quite a difficult one to work out. We'd definitely need our calculator on this one. But any of these recurring decimals, in fact, that start with the recurring part starts in the 10th column, are easier than you think they're going to be. So I'm not too worried about this. And I'll show you what I mean. If I do my working out up here, so I've got 0. Well, here's my 142,857 recurring part, all of that, already where I want it in my 10th column. Then I'm going to just remove all of that and all of the other ones that are implied that go down here. So I want my other, the number that I subtract from, to be also 142,857. Okay. So how am I going to get that? Well, I haven't got any other numbers to play with here, so that 0 doesn't count for anything. So I'm just going to multiply it up until I get this the other side, and it starts recurring again. In other words, I'm going to just move this number loads to the left until I get to, I'll have to work backwards here, 7, 5, 8, 2, 4, 1. Okay. Done that decimal point a bit high, so I'm just going to be a bit fussy here and move it down just a bit. There we go, like that. Okay, now I ask myself, what have I done here? Well, here I simply done times 1. Here, well, I've moved all of this to the left a load of places. How many places? Okay, so it's gone, this one's gone here, so that's 1, 2, 3, 4, 5, 6. So I must have, in fact it's fairly straightforward, I must have multiplied by 1 million to move it 6 places. Yeah? If I move by 1 million, I should get, if I multiply by 1 million, I should get it moved all the way up to there, and it starts recurring again. So what have I got here? I've got 1 million. And squash those millions up so that I can see them clearly. Subtract, well, times 1. Subtract 1. Gosh, 1 million subtract 1 is pretty easy. I just need to make sure I get the number of 9s correct. Well, if there are 6 zeros in 1 million, then there must be 6 9s in 1 million subtract 1. So 999,999. Okay, enormous number here, but with some nice, some quite friendly figures to work with. My answer was what though? My answer was, well, I can cancel this now, which is very nice, and I've got then 142,857, whatever that is, 142,857, subtract 0. So in other words, it is 142,857. 142,857, so big number. And I divide by 999,999. I reach for my calculator, and I'm hoping it's going to be a 12th. Sorry, not a 12th, a 7th, because that's how I got my decimal to start with. So, are we going to get a 7th? Let's type the numbers into the calculator. Hit the equals button, and sure enough, very satisfying result, we have a 7th. Great, let's give this a go. I don't want to end on that one because that's a bit of a gasper. Let's just erase our working out then and do one more. Alright, so erase all of this. And we'll move the hands of the clock. You might be able to guess which is the fraction that I've prepared for this, but try not to guess. Let's just see if we can use our skills here. So I've moved the hand of the clock a little bit anti-clockwise, and we've got this proportion here. So what proportion of an hour is this fraction represented here? Okay. Well, my calculator tells me it's this rather nice number, 0.0909090909, going on and on forever. Okay, let's erase all those. There we go. Now what have we got? We need our dots above here, and we're going to start immediately. It's nice and straightforward. We've got times 1 because we've already got our recurring part. So the 0 is part of the recurrence. I suppose that's the mistake that people could make here. They could think that because it's a 0 it's not recurring, but it is, otherwise we would just get 99999. Yeah? So it's worth just noting that and making sure we don't make that mistake. Okay? So it's 090909. So my 0, my recurring 0, is already in the 10th column, so I want to have the number that I subtract from to have the same pattern. But I need to remember my 9, so I'm just going to bring these to the left. Okay, so what have I done? I've multiplied by 100, haven't I? 1, 2. So it's moved to the left 2. So in other words, times 100. So to move it to the left 2, I've multiplied by 100. And that means, well, I don't need this 0 anymore, do I? So I can erase that. That means I've got my two figures here. Okay. And I can subtract. Let's write my two figures in. So I've got 100 subtract 1, which is 9. 99. Let's not go too fast to make a mistake. It's surely 900 subtract 1 is surely not 9. So okay, we're good. Now we need the answer. So what's 0 from 9? Well, it's just 9. So we can put equals 9. Okay, so lots of 9s going on here. So now let's move to the point where we calculate this out. So we've got 0.09 times 99 equals 9. So if 0.09 recurring times 99 equals 9, then we want a 99th of 9. So we've got 0.09 recurring equals 9 divided by 99, or 9 99ths, which is another way of thinking about it. And now we can divide out, so we can reduce this, simplify it to divide by 9, 1, divide by 9, 11. Okay, so that's how we convert recurring decimals to fractions. If they're not recurring, we can use the method we showed in the previous video and in summary at the start. But if there are recurring parts, then we need to work through this method that I showed you here. Okay. Okay, so just a philosophical conundrum to finish with. This often comes up and it's a really nice one to think about. 9.99999, so the 9 is recurring. What have we got here? Have we got 10 or have we not got 10? Well, you can probably guess the answer already. So it's a good one to pose as a philosophical problem and see what answers people come up with. They can have an argument about whether it's 10 or it's just 9.9 going on forever. Let's have a look using our method though. So this time I'm going to write 9.9 recurring like that. Do our working out here and say that that's times 1. And therefore, if we just move 1 to the left, we've got 99.9 recurring. That's our times 10. In other words, if we subtract this one from this one, we get 90. So 9.9 recurring must equal, well, times 10 subtract 1, in other words times 9, let's write it out in full, 9.9 times 9 must equal 90, and if 9.9 times 9 equals 90, then 9.9 recurring is a 90th of 90, a ninth of 90 rather, 90 divided by 9. Okay, and therefore 9.9 recurring equals well, divide by 9 both top and bottom, 10. So an interesting one to very quickly work out using the method that we've just been using. Pose this as a problem, as a philosophical conundrum, and then give the answer quite confidently that 9.9 recurring equals 10. Okay?